Bismillahirrahmanirrahim. How are you, students? Today we will do numerical problems of chapter number 10, thermodynamics. Today is lecture number 49. Now, students, the first numerical is water at 20 degrees Celsius. So, temperature is T1 is 20 degrees Celsius. So we will convert this temperature into Kelvin. In Kelvin it is equal to 293 Kelvin. We will add 273 to this and height, from a height of 854 meter. So height is equal to 854 meter. This is the height. Now the whole energy is used to increase the temperature. Find out the final temperature T2 question mark. The specific heat is 4200 joule per kilogram per Kelvin. So you will use, as we know that del Q is equal to Cm del T. Is equal to Cm T2 minus T1. This is del Q, and potential energy is equal to mgh. As we know that del Q is equal to Cm del T, when water falls from certain height, its potential energy will be changed into kinetic energy and then will be converted into heat energy. Therefore, we will consider potential energy. Now this energy is converted into del Q. So I will erase this one and will write again. You will write del Q is equal to potential energy mgh Cm T2 minus T1. M is cancelled, and after simplification you will get the value of T, or just write T2 is equal to GH divided by C plus T1. Use this equation, you will find out the value of T2. Now the second numerical is 2520 joule of heat energy. Joule of heat is supplied. How much heat is supplied? 2520 heat is supplied. So del Q is equal to data. Del Q is equal to 2520 joule, while the system does 6000 joule of work. Del W is equal to 6000 joule of work is done. Find the change in the internal energy. Calculate the change in the internal energy, del U. So equation is del U is equal to del Q minus del W. You will get the answer. Now 10.3. A sample of ideal gas is uniformly heated at constant pressure. If the amount of 180 joule of heat is supplied, del Q at constant pressure is equal to NCP del T. This is the formula, and it is equal to 180 joule. Del QP is equal to, I have write the formula for you, and del QP is equal to 180 joule at constant pressure. Calculate the change in internal energy of the gas and the work done. Change in internal energy and del W. This is question mark. Now del qp is equal to ncp del T. So we will write, we know that Cp divided by Cv is equal to gamma, and we know that Cp is divided by Cv is equal to 1.41. This is given. So Cp is equal to 1.41 Cv. Put this value in this equation. Del Qp is equal to Ncp del T. So write the values. Del Qp is equal to 1.41 Ncv del T. N is written here. In place of this, we will write C and Cv and del T question mark. Now, per isochoric process, del W will be equal to 0 per isochoric process. So del Q is equal to V is equal to del U. So you will write del Qp is equal to del Qp is equal to del Qp is equal to 1.4 Ncv del T. I have written again it. Now del Qv is equal to, we have written it on the previous page that del Qv is equal to del U. So del U is equal to Ncv del T. Del Qp is equal to 1.41 del U. Del U is equal to 180. The value of this is 180. Divided by 1.41. You will get the answer. Now del W is equal to del U plus del Q minus del U. Del Q minus del U. You have the value of del Q, you have the value of del U. Put the values and get the answer. 180 minus 1, 27.66. You will get the answer. Now 5 moles of oxygen. 5 moles of oxygen. Number of moles oxygen is heated at constant volume from 10 degrees Celsius to 20 degrees Celsius. T1 is 10 degrees Celsius. T2 is 20 degrees Celsius. Del T is equal to 10 degrees Celsius or 10 Kelvin. The difference of temperature in both is equal. On both scales is equal. Now the next is, what will be the change in the internal energy of the gas? We have to calculate the internal change in the internal energy. Del U question mark. Del U question mark. The specific heat of oxygen at constant pressure is 8 calories per mole per degree Celsius. Per degree Celsius. 8 calories per mole per degree Celsius. 1 calories is equal to 4.2 joule, and Cp is equal to 8 multiplied by 4.2 is equal to 33.6 joule per mole per Kelvin per degree Celsius. Now internal energy is question mark. For isochoric process, del Q is equal to del U. So del U is equal to NCV del T. NCV del T. NCV del T and Cp minus Cv is equal to R. We have to use these formulas. So Cv is equal to Cp minus R is equal to 33.6, which we have calculated, and R is 8.36. This is constant, joule per mole per Kelvin, minus 8.36. So Cv is equal to 25.2 joule per mole per degree Celsius. This is the value of Cv, and del U is equal to, in Cv del T we have already written this one, number of moles is 5, 25.2 multiplied by 10, you will get the answer. Find the efficiency of Carnot heat engine working between the steam and ice. Working between the steam and ice. Temperature of steam is T2 and is equal to 273 Kelvin. In Celsius it is 0 degree Celsius. This is T1. T2 is this is T2. T1 is boiling temperature. T1 is 100 degrees Celsius, is equal to 373 Kelvin. So efficiency is equal to 1 minus T2 divided by T1. Percentage efficiency, so multiplied by 100%, you will get the answer. Carnot heat engine absorb 2000 joule of energy. So heat absorbed is 2000. Heat absorbed is 2000. This is numerical 10.6. Q1 is 2000 joule. 2000 joule. Q2 is 1200 joule. Percentage efficiency is equal to 1 minus T2 divided by T1 multiplied by 100%. Percentage efficiency is equal to 1 minus, it is in term of temperature. In term of heat it will be Q2 divided by Q1. 2000 divided by 1200 divided by 2000 multiplied by 100%, you will get the answer. Now during each, calculate the efficiency of engine, temperature of sink, and amount of work done. So now we will calculate the temperature of sink. So for temperature we will do efficiency is equal to 1 minus T2 divided by T1. We will use this formula. T2 is the temperature of sink, or write capital T2. both mean same thing. Now we have already calculated the efficiency, so you will use the formula. You have calculated the efficiency from the formula 1 minus q2 divided by q1. Use the same formula, take the efficiency and use this formula. You will calculate the temperature of sink. A Carnot engine absorb heat, so temperature of T1 is 227. 227 is the T1 temperature of HTR, high temperature reservoir. So convert it into Celsius. It is 600. So 1 efficiency you already calculated from the previous formula. Write T2 and here you will write 600. Simplify, you will get the answer. In a refrigerator, heat from inside at 277 Kelvin is transferred to a room of 300 Kelvin. So T1 is 300 Kelvin and T2 is 277 Kelvin. How many joules of heat will be delivered to room for each joule of electrical energy consumed ideally? Now T1 we have work done. Work done is given? No. How many joule of heat will be delivered? Now T1 is given, T2 is given. Coefficient of performance we have to calculate, and hence we have to calculate Q1 also. So coefficient of performance is equal to T2 divided by T1 minus T2. 300 divided by 300 minus 277. It's 277. You will get the value, which is 12.04. Now Q1 coefficient of performance is also equal to Q1 divided by del W. In a refrigerator is transferred to room, how many joules of heat will be delivered to the room per each joule of electrical energy consumed ideally? In daily it consumes 1 joule of energy. Ideally it consumes 1 joule of energy. There is mistake in the reading. So Q1 is equal to coefficient of performance and del W. So coefficient of performance is 12.04, del W is 1, so you will get the answer. What is the least amount of work that must be performed to freeze 1 gram of water at 0 degrees Celsius? So we have to take mass of water is 1 gram. Temperature T2 is 273 Kelvin. T1 is 37 degrees Celsius is equal to 307 Kelvin. 310 almost. 273 is added. Latent heat of fusion is 336 joule per gram. So heat extract will be equal to MLF. Use this formula, you will get Q2. Del W question mark. Now you will use the formula coefficient of performance Q2 divided by del W is equal to T2 divided by T1 minus T2. So you will find the value of del W is equal to Del W is equal to T1 minus T2 divided by T2 multiplied by Q2. Use this formula, find the value of del W. And del W is also equal to Q1 minus Q2. So we have to find two values. Calculate the change in entropy when 10 gram of water is heated from 90 to T1 is 90 degrees Celsius. In Kelvin it is 363 Kelvin. T2 is 100 degrees Celsius, 373 Kelvin. Del T is 10 Kelvin or 10 degrees Celsius. Mass is 10 kilogram. Specific heat is 4180 joule per mole per Kelvin. Now del Q is equal to Cm del T. Del S is equal to, you will find the value of del Q by this formula. You have the specific heat, you have the mass, you have the temperature difference, and del S is equal to del Q divided by T. So write the value of del S also. Now last numerical. A system absorbs 1176 joule of energy. So del Q is equal to 1176 joule of energy. At the same time, so much amount of work is done. Del W is equal to 352.8 joule. 352.8 joule. So del Q is equal to del U plus W. Del W is given, del Q is given, you can find the value of del U. So do it. Now find the change in the internal energy. You will do it by you as a home assignment. If heat absorbed is changed, del Q heat absorbed is changed, it is equal to 1050 joule. And work also change, 84 joule of work is done. Then find what will be the change in the internal energy. So del U is equal to del Q minus del W is equal to 1050 minus 84. You will get the answer. Now next is it's 966. Now of the gas, if 10 joule of heat is removed at constant volume. Now how much heat is removed? Remember the data. Del Q is equal to minus 210 joule of heat is removed at constant volume. Del W is equal to P del V. P, change in volume, is 0, so work is 0. Del Q is equal to del U is equal to del U is equal to del U is equal to del Q, and del Q is equal to minus 210 joule of energy. So this is the answer. These are the numerical. Your syllabus is finished. Tomorrow inshallah we will do the short answers. Thank you students. Allah Hafiz.